Hey guys, and welcome to how to find the inverse. And we're going to be going along with the Missy Elliott song Work It for this, which is put that thing down, flip it, and reverse it. This by no way is endorsed by Missy Elliott. However, she may be a secret mathematician. Alright, so the steps, exactly what we said. Put that thing down, which is basically just going to mean flip y for f of x in our function. Flip it, you're going to swap out x and y, reverse it, solve for y, and then stick it in inverse notation. Y is going to go back to, y is going to change to the notation of f inverse of x. So really simple. Just remember, put that thing down, flip it, reverse it, stick it in inverse notation. So here we go. Let's see some examples of this. We're also going to see some stuff that involves restricted domains. So let's find the inverse of f of x equals 2/3 x. Step 1, put that thing down, sub in y for f of x, 2/3 x, flip it, sub x for y, so flip it, 2/3 y now, reverse it, solve it back for y, so x equals 2/3 y. How do I solve for y? Use the reciprocal of 2/3, which is 3/2. 3/2 on both sides. So I would get 3/2 x is equal to y. Okay, put it in inverse notation, get rid of that y, and let's use our nice fancy f inverse of x equals 3/2 x. So if f of x equals 2/3 x, then f inverse of x is equal to 3/2 x. Notice that this function is also one-to-one, the 2/3 x, because it is a linear function and all linears are one-to-one. So because this is one-to-one, we were also able to find the inverse. Alright, let's see another example. So find the inverse of this guy, 2x squared minus 5, on the domain, though, such that x is greater than or equal to 0. So notice if we did not restrict the domain, because this is a quadratic, right? What do the graphs of quadratics look like? They're the U. These guys, without restricting the domain, fail the horizontal line test, not 1, 2, 1. So without the restriction of the domain, we couldn't do this, okay? But we are restricting the domain, so we're not saying, hey, both sides. We're basically saying, hey, I only want to do the inverse for the positive side, and I'm basically going to do this and like entirely ignore the negative side. Oh, look, now that piece of the function, that's going to pass the horizontal line test, and it passes the vertical line test. So by restricting the domain to only the x is greater than or equal to 0, we are going to be able to find the inverse of this. So that's this whole point here for the x is greater than 0. Okay, so that being said, put that thing down, put that y down, 2x squared minus 5, flip it, x equals 2y squared minus 5, reverse it, let's solve it for y. So the first thing that we are going to do is add 5 on both sides. Add 5 on both sides, and which gives us x plus 5 equals 2y squared. Next, let's divide everything by 2. So again, we're just solving for y here. This is the reverse it step. So x plus 5 over 2 is equal to y squared. So our last step here, we're going to take the square root of everything, and usually we would have the plus or minus square root in this case, but because we're only dealing with positives, we're not going to do that. We're just going to say y equals the square root of x plus 5 over 2. And we're just going to take the positives because we're only dealing in positives because we restricted the domain. Now step 4, put it in inverse notation. So f inverse of x is equal to the square root of x plus 5 over 2. So f inverse of x is equal to the square root of x plus 5 over 2. Now what's our domain here? This will be valid for all x's greater than or equal to negative 5. Because notice if we put negative 5 in there, negative 5 plus 5 is 0, 0 over 2 is 0, square root of 0 is 0, we're all good there. However, if we go anywhere less than negative 5, we create a negative under the square root, and that is also no bueno. So we don't want that. So our inverse function is going to be square root of x plus 5 divided by 2 for all x's such that they're greater than or equal to 5. Alright, let's keep going. Okay, let's find the inverse now of f of x equals square root of 3x minus 4. Step 1, put that thing down. Also notice we don't have a restricted domain here because we don't need one, right? What's the graph of the square root function kind of look like? It's kind of like this parabola that's laid on its side, but only a piece of it. That passes vertical line and horizontal line test. This guy is 1-to-1, so we don't need to worry about restricting any kind of domain. So let's keep going. Put that thing down. Y equals square root of 3x minus 4. Flip it. X becomes y becomes x. 3y minus 4. Reverse it. Let's solve it back for y. So when we reverse it, let's see, x equals 3y minus 4. I need to get that square root away. What's the inverse operation of square rooting something? Squaring. So we square, and we get x squared equals, now the square and the square root cancel out, so that thing basically just pops right off. X squared equals 3y minus 4. Let's get rid of the 4 next by adding it to both sides. So now we have x squared plus 4 equals 3y. Last step, let's get rid of that 3. We're being multiplied by 3, so let's undo that by dividing, just inversing all over the place. So we have x squared plus 4. The whole thing is going to get divided by 3. Now that is equal to y. Step 4, put it in inverse notation. Y now becomes f inverse of x equals x squared plus 4 divided by 3. So our inverse here, again, x squared plus 4 divided by 3. Let me actually make that look like an f. There we go. Okay, so again, what is our steps? So if I blank this out, anytime you need to find the inverse, A, make sure it's 1-to-1, or make sure the domain is at least restricted enough so that that particular piece of the function is 1-to-1, and you can find the domain on that set. Then put that thing down. In other words, just take out the f of x and put a y. Flip it. Okay, now flip x and y. Reverse it. Solve back for y. Put it in inverse notation. Take out the y again. Put an f inverse of x. And you're good. So thank you. If you have any questions, just always let me know. And I hope that helped you guys with inverses.